This is a running scientist, and this is a continuation of Unit 8 Worksheet 1 mole relationships, and we're going to look at the last three problems there. So problem number 4. Poison gas phosgene reacts with water in the lungs to form hydrochloric acid and carbon dioxide. How many moles of hydrochloric acid would be formed by 0.835 moles of phosgene? Well, as usual, we've got to start with the formula. So phosgene, CoCl2, reacts with water, and we can probably guess almost off the bat that the water is going to be in excess to form hydrochloric acid and CO2. So from there we got to go ahead and balance the formula. Looking at this, we got 2 chlorine, 1, so we know we need a 2 there. And let's see, 1 carbon, 2 hydrogens, 2 hydrogens, 2 oxygens, so it looks like we're balanced. Alright, so we're starting with, again, our products. Nothing about the products in the problem. We want to know how much. So we're starting with 0 because we haven't formed any. And we have 0.835 moles. And again, if you look at our ratio, it's 1 to 1, 2 to 1. So the change, we are definitely going to use all this up. We are going to use up 0.835 of this, but again, this is going to be in excess. This is going to give us 2 hydrochloric acids, so we know from the ratio that this is really 1. So 2 times that is 1.67, and again, this is a 1, so not a whole lot different here. 0.835. And again, we're getting these numbers from this ratio. So this is what we have. We're given 0.835, and we know the coefficient is 1. So it's pretty simple math there. So this is done. This is going to be in excess, and we're getting 1.67 hydrochloric acid and 0.835 of the CO2. Pretty straightforward one. Let's look at problem number 5. Iron, metal, and oxygen combine to form the magnetic oxide of iron, Fe3O4. How many moles of iron can be converted to magnetite by 8.80 moles of pure oxygen? Alright, let's see what we got. Got to write the balance formula. So we got iron and oxygen. Remember, oxygen is diatomic. Now this is saying we've got pure oxygen, so this is the one that's going to get used up. So I'm going to assume here we've probably got the iron in excess, and it's going to form magnetic oxide, Fe3O4. And that's balanced for charges, but now we need to balance for the for coefficients, for the number of atoms on each side. Well, 1 iron, and we've got 3 here, so definitely this is going to be we're going to need a 3, 2 oxygen, 4. So it looks like we're going to be in that order there. So for 3 moles of iron, I'm going to react with 2 moles of oxygen to give you 1 mole of magnetic oxide of iron, Fe3O4. So we got our 4, and we have 8.80 moles of this. So we don't have that. Again, that's before no reaction take place. And we've got to know how much of this do we have. Well, this is going to be in excess, but we still got to burn some of this up. So we can do our ratio 2 to 8.80 as 1 is to x. 2x equals 8.80, x equals 4.40. So we have that. Let's do our change. Well, we gotta burn up 3 moles of this, of iron, and we know 1 mole is 4.40. So if we do the math, 3 times 4.4 is 13.2. We know we're going to run through all of this, 8.80. And the coefficient of here is 1. And so 1 times 4.4, that's 4.40. So then we can do the after. We're going to use all this up. If we changed this by 13.2, that's how much we used. This is still going to be in excess here, because that's how much we used. This is all gone, because this is what we were given. So we needed to use all of that up. So we got to have some extra iron. And we're going to get 4.40. And how many moles of iron oxide would we produce? There's our answer there. So again, pretty much the same thing we've been doing. Just a little bit different twist on it, but the procedure really remains the same. Alright, let's look at the very last one here. And again, I'm not going to read through this whole thing. We are given the equation for, I guess, CocaCola Classic. And so we can go through and do our before and our change and our after. So we got 1 part, or 1 mole of caffeine, reacts with 4 moles of phosphoric acid and 6 moles of CO2 plus a bunch of other stuff to give you 1 mole of potassium benzoate and a bunch of other stuff. So it's a 1 to 4 to 6 to 1. So let's do our before. And let's see, we'll have our change, and then we'll have our after. And we got 0.21 moles of caffeine. So we know we got 0.21 moles of caffeine. And we know we don't have any products yet, so that's going to go to 0. So the coefficient of caffeine is 1. So 1 is to 0.21. So what's 4 times 0.21? That's going to be 0.84. And that's of the phosphoric acid. And 6 times 0.21 is going to be 1.26. So we definitely are going to use up all of this. I forgot my 0 there. 0.21. So we're going to use up 0.84 of this, and we're going to use up 1.26. And this again has a coefficient of 1. So 1 times 0.21 is 0.21. So the after, this is all going to be gone. Looks like this stuff is going to be in excess. We're going to use that much, but it looks like we got extra of this. And we're going to form 0.21 moles of the potassium benzoate. And we want, let's see, how many moles of that? How many moles of phosphoric acid are required? Well, actually 0.84. How many moles of carbon dioxide are required? 1.26. So I guess I am mistaken here. This is not going to be in excess, and these are going to be in exact amounts. So for this reaction to take place, we need 0.21 of caffeine, we need 0.84 of phosphoric acid, and 1.26 moles of CO2. So that is that reaction, because they're saying everything's going to completion there. So that we won't really have anything in excess here. and it's going to end us up with 0.21 moles of potassium benzoate. So that's the second part of that.